What?
Alright, so
Ryan.
a water tank has the shape of an inverted circular cone. What does that mean?
Ice cream cone.
It's a
It's a
cone.
waffle cone. Upside down cone. Alright? So we should probably start out by
Area.
drawing ourselves a nice
Oh.
picture.
Oh,
I don't really know how to
Just
draw
made
a
a perfect cone picture.
How the
Let me see.
turntables
Let me
have turned.
Oh my goodness. That is beautiful.
Show the class.
Is it more beautiful?
No,
Sure.
look at it, Miss Douglas. It's
Sure.
literally like it was printed on that paper.
Wait, share.
Can I
Share
copy
with
your
the
mouse?
class. Yo, share.
The
Share with the class.
I've been
Base
trying to copy you.
radius
Mm.
is 2 meters. So radius is
How? What?
halfway across. And the height is 4 meters. Water is being pumped into the tank. So I'm pouring water in at a rate of 2 cubic meters per minute. What would that represent?
Derivative of one of the things.
Alright, if it's cubed, it would be
Volume.
volume. So
Ooh.
dV dt is 2. Find the rate at which the water level is rising. So as we pour this in, we know the water level is going up. So what am I looking for?
Area dA dt.
The height.
Oh. Oh man.
When the water is 3 meters deep. So at the point I'm looking at, the H is
3. I don't know why that sad clown Carson was so fun.
What?
alright. Volume of a cone.
1/3 pi r cubed squared then.
So it's like area base pi r squared times the height. And it's 1/3 of a cylinder. So 1/3 pi r cubed. Okay. Here's the problem. If I do this derivative right now. Okay. So I would have like, don't write this down, just watch for a second. dV dt. This would be like pi over 3, but I have 2 variables. So we would end up doing a product rule.
Yeah.
Right? And so I would get like 2 pi over 3 r dr dt h plus pi over 3 r squared dh dt. Which doesn't seem all that bad, but I have dv dt. dh dt is what I'm trying to solve, so that's got to stay. Did I give you any information about the radius? No. So I really need to get rid of that before we do the derivative. Because if I don't, I'm going to have a dr dt in here. And I don't want that because I don't have anything to plug in. Did I give you any other information about the radius?
It's
2 meters.
Okay. I'm looking at the entire thing. Okay, so this entire cone. The height is 4 and the radius is 2. Alright, the point I'm looking at, I'm just going to call this H and R. These would be similar triangles, right? So I could say like 2 over 4 equals R over H.
What?
R equals 2H.
Probably 4R equals 2H. So
Oh, I simplified
R
that
is
fraction.
H
1/2.
over 2, or 1/2 H.
Wait, could you not simplify?
Yeah, but 2 over 4 is 1/2.
Yeah, 1/2. And then
1 your H.
that way, yep.
So, radius is half the height.
Why did we do that?
Because
Why did we make it a triangle?
I was trying to relate it to similar triangles. If you're thinking about the whole thing, that's forming the right triangle, the radius and the height.
Okay.
I don't think you would. Could I solve it leaving it by the r and just keep the rate of r as 0?
Because the radius is changing. So there is a rate of change in the radius. We just don't know what it is.
And that's just the water
Okay.
filling up is different. Okay.
So
I see.
R is not a constant. It is changing. But because I gave you no information about it, I am going to rewrite it in terms of my height. Just to give me fewer variables. So 1/3 times pi is pi over 3. My r is 1/2 h squared times h. So that's like pi over 3, 1/4 h squared h. So volume is pi over 12 h cubed. So we did a little extra work to start with, but now what do I have to do to this? Before we plug in, we have
No,
to
you
do
were.
derivative.
I thought we had already done that for some reason.
Well, I did, but then I undid it because it didn't help us. So derivative of v is dv dt. Okay, over here the 3 comes down, pi over 12 times 3 is pi over 4 h squared dh dt. Plug in what we know. So dv dt is 2 equals pi over 4. H is 3 squared. We don't know dh dt. So dh dt is 8 over 9 pi. What would my units be?
Meters per
Per
minute. Per minute. I was trying to figure out if there was any things.
Okay, so the whole reason we had to get rid of that r is because I wasn't solving for dr dt. I was looking for a different rate, but I didn't tell you what it was. We can't solve if we have 2 unknowns in the same problem. So I tried to get rid of my radius before I did the derivative, so I would not have that dr dt. So multiply by 4 and divide by 9.
Oh, the pi can't just go anywhere. It's gonna be on the bottom.
It is on the bottom here. Other questions? Let's try another one.
I feel like I'm drawing snow cones and not really like waffle cones.
We skipped this one yesterday, right? I
Correct.
did 9. Alright, so we have a funnel in the shape of an inverted cone.
Number 2 on second.
Come up and draw mine for me.
I had a snow cone.
It is 30 centimeters deep. The diameter across is 20, so the radius would be
15.
liquid is being poured in at a constant rate. Did I tell you what that was?
No, that's where DVDT we're
Okay.
looking for.
And is flowing out at a rate of 12 cubic centimeters per second. So we have 2 things going on. We have water coming in and spilling out the bottom. Okay. The height is rising at a rate of 0.25 centimeters per second. So that would be,
DHDT.
if I had said it was falling, what would you do?
There you
At the instant when the liquid in the funnel is 20 centimeters deep, so that would be, we're trying to find the rate the water is being poured into the funnel. But that's not just the volume, is it? Because I have water coming in, I don't know how fast, let's call that C. And then it's coming out at a rate of 12, so that would be like a negative. So my overall volume would be what?
C minus 12.
C minus 12. The amount coming in minus the amount going out. That's the volume in the cone at a given point in time. Alright. We know volume of a cone
So are we looking for what, DCUT?
We're looking for just the C
Okay.
here. Is r 1/3 pi r squared h. But if I do this derivative right now, I'm going to end up with a dv dt, a dr dt, a dh dt. I don't want the dr dt.
Are we doing the
Pi over 12 h cubed.
the triangles again?
Yes.
Oh,
So we need to think in this one, the height was 30, radius is 10. So I could say 10 over 30 is equal to r over h.
H over 3.
R is h over 3, or I'm going to write it as 1/3 h, but it's the same either way. So the radius is just 1/3 of the height. And I need to plug that in before I do my derivative. So 1/3 times pi, I'll write that as pi over 3, and radius is 1/3 h squared times h. Okay. Pi over 3. 1/3 squared is 1/9 h squared times h. So we get pi over 27 h cubed. That's my volume. You guys with me there? Now what do we do?
Theory DT.
So if we bring the 3 down, pi over 27 times 3 would be pi over 9 h squared times,
H.
so we plug in, dv dt is c minus 12. H is 20. dh dt is 0.25. So 20 squared is 400 times 0.25 is 100 times pi over 9 would be 100 pi over 9. So we get C, we just add our 12. And you could certainly put this in a calculator to get a decimal, but on test we won't have that option, so let's just leave it like this. What would my units be?
Centimeters cubed per second.
So that's how fast we are pumping the water in.
How do we know it's cubed?
Volume.
Volume is always cubed. The amount.
This pen really bleeds too.
Oh, that's sad.
It's a good pen though, so super care.
My favorite though is good pencil. Don't bleed. All right. Is that okay?
Right triangle.
One more. Why don't you guys take a minute, read this, and see how far you can get with it before we work it out. All right, how far did we get?
I wrote an equation, but I don't think I did it right.
I'm so close.
So what'd you do first?
I drew my triangle.
We have a right triangle. Alright, and I told you the height is 1/3 the length of the base. So, what variables did you use?
B.
B, so then the height would be 1/3 B. And that's preferable to using B and H because we don't want to do a derivative with multiple variables if we can avoid it, right? How fast is the area changing? So I am looking for
Derivative A.
dA dt. When the height is 5 centimeters, so I gave you the height is 5, and it's increasing 2
Oh.
centimeters per second. So that's dH dt.
I don't know why that was so silly goose to me. That means B is 15.
Okay, so we have an issue here, don't we? So area of a triangle is 1/2 base times height. We set this up so we had only B's, but the information I gave you was
B and H.
we could certainly find the base if the height is 5, but can we find the rate of change of the base from that? No. So really, H is going to be the variable I want to keep. All right, so let's think about this. If I just said this is H and this is B, and I told you that the height is 1/3 the base,
3H.
then the base would be 3H. Do we agree with that? So that's what I'm going to replace over here. So I want to keep my A because I have a dA dt. I want to keep my H because I have a dH dt. But I don't have a dB dt. So I'm going to replace my B with 3H. So my area is 3/2 H squared. Now, if I had given you dB dt, would this be necessary?
No.
No. But because we didn't have it, we need to get rid of it before we do our derivative. So now our derivative, this would be dA dt equals 3H dH dt.
Wait, why did everything? Oh, yes, of course, math. For some reason, I tried to square that fraction.
Plug in our step. So dA dt
6.
is 30.
I missed another number.
And area would be
Squared. No, regular. No, squared.
square centimeters
in a second.
per second. So my area is increasing 30 square centimeters per second.
I was all over it until I got to the part with the B, and then I was not
I
on it.
was almost there, but I chose to keep the wrong.
Did you do okay?
variable.
You kept the 1/3.
Kept the B's and then you didn't have to.
Well, in the moment you
Well,
said, I
changed
was
it
like,
over to X.
I knew because I looked at this and I thought, man, I don't have a dBdt and a dHdt. Huh. Or, I mean, I don't have a dHdt.
I was trying to figure out how to get
Yeah,
a
no.
dx dt from the dy dt.
I just didn't want to deal with fractions, so I was like, it'd be so much simpler if I just made the 3.
See? Isn't that great? All right, we're on day 3.
We get it, we're genius.
Grace is an accidental genius.
If I have.
This is going to be due Friday.